All right. Good morning, everybody. Thank you so much for the introduction. Thank you so much for the invitation. And as far as languages are concerned, I am able to understand a few. I'm not really able to speak that many, and we'll touch upon that point, right? So what does it mean to really understand patterns? Because that's what language learning and using languages is all about, to my mind. However, what we are primarily talking about today would be big data and big systems. And the big question is, are these big data also smart data, right? Because being inundated with big data, that is one thing, and that is certainly true for all of us, but how can we make these systems smarter? And really, it's a collection of rather trivial things that I feel I will be talking to you about today. But when viewed in the correct light, trivial things can sometimes start opening eyes, I think. So let's start. When talking about big data and smart data, one word that springs up all the time is semantic web. So what is that really? And we may really pose the question to the world, where art thou? Right, in a somewhat more archaic English, somewhat poetically, where art thou, semantic web? Well, is it really there? That is a question that many would contest, and amongst them also Tim Berners-Lee, really the father of the web. When talking about the semantic web, that would mean how to find really structured and reliable information, not just the web where everything is somehow interconnected, but also the web that is structured and everything leads logically to different other pieces and elements. Now, the reality that we all face is that we're simply inundated with data, right? So we have all of these different systems and applications around, and this is really just a small view into what is happening all the time, right? So every 60 seconds, there are these huge platforms such as Google and Amazon and YouTube. But let's talk about the library world as well, where perhaps the amount of information that is being exchanged every 60 seconds is a little bit lower, but still, how can we make sure that all of this information is really interconnected and really structured? So finding information in libraries is not without challenge. When we ask researchers and we ask users of libraries how they are actually spending their time, most of the time what we hear is that the majority of the time goes into searching for content. It's not really working with content that much. That is the last step, but searching for it and finding appropriate and really reliable information isn't always that easy, it seems. And indeed, the majority of our time goes into that. Now, 45% of digital library users do express frustration in finding content. So it's not just time consuming, it's also apparently not easy at all. And 84% of all users start their search somewhere else on the web. That is a somewhat sad truth. You may say that most users of libraries, or most people who have access to a library, actually do not start their search within the library. Most of the time, we start somewhere on Google Scholar or Wikipedia that are not citable sources. Everybody knows that Wikipedia is not really a citable source, but it's good for finding initial information, and that's what apparently almost everybody is doing all the time. Now, let's have a somewhat closer look at Google Scholar. Of course, it's a scholarly engine, right? So it's not Google as such, where you will find lots of cat pictures and all of that. So inappropriate content for a scientific search, but it's still Google. And that means that searching for something such as education or media might lead to, again, a flood of information. And is that information really ordered according to its relevance as we would expect it when trying to write a scientific article, when trying to work with a library? Because one question that should always be asked is, how do search engines actually actually find relevant results? What are the major criteria for delivering always relevant results? Now, one thing that we know about Google, whose relevance algorithm is quite sophisticated, and other search engines, is that linking popularity does play a very large role. Of course, it's always a mixture of things. It's always a mixture of, for example, the publication date, the actual title, the origin of a specific article, then its abstract, the full text itself, and so on. Although the full text can sometimes be misleading, as we all know, because the longer the text, the higher the probability that specific words turn up. That might not necessarily be actually related or very relevant to its content. Now, that leaves one thing sort of outside the picture, as we might have noticed, and those would be the subject terms, very dear to the hearts of every librarian. And that means that we are missing something very important within that big picture if we're going only by, not only, but majorly by linking popularity. So subject terms are something that should always be considered and always be gathered and always be curated in a way that makes things very, very relevant and actually true to their source. What about subject indices? Right, so those would be the smaller discovery services, if you will, that were there even before the large discovery services were there, the large discovery indices. Those are the somewhat smaller but very subject-specific indices that should not be left aside. So it's always a good idea to have a look at what is happening within these subject indices to familiarize oneself with the thesauri thereof, and to be aware that they exist, firstly, and secondly, to make sure that they are always connected with anything that we are using as a larger system. Because even when we have all these subject indices and they might be connected to our larger systems, let's have a look at some of these subject headings therein, and they can indeed differ substantially. So let's pick that very same educational media that we were looking for in Google. And within ERIC, for example, it is called as such. The moniker is the same, educational media. But then again, when we go into GRF, the piece of controlled vocabulary that is used for that very specific discipline is educational resources. So we see a little distinction, a little difference there already. It's the same thing essentially, but it's called somewhat differently. Now, when we go into MLA, it's the same area that is being covered, but by a different controlled word within that controlled vocabulary. Instructional materials. It is a completely different juxtaposition of words. It's not educational media, but we should be aware that that is exactly what we should be accessing when we want to get the same content. And you can see that the differences abound. So it's important to have these connections established between the different versions of specific words and vocabularies. Then also multilinguality is a very important point, because we live in a multilingual world. Yes, the world is becoming more and more English, of course, but that doesn't mean that we should leave aside all of the differences that are there when it comes to language. And they should be not just gathered through some means such as Google Translate or something like that, but we should make sure that we actually draw the right connections. So structure is very, very important. Then when we are talking about the library world, of course, there are such tools such as national authority files, different individual smaller thesauri, different individual taxonomies, mesh in the medical world. And we all know that this is the situation that we're dealing with, right? So Dostoevsky is, of course, a well-known name, but that name has very, has numerous different variants. So how do we get to all these variations? We should make sure that the data that we're using in our larger systems are also structured accordingly, and that, for example, national authority files are always taken into account. Then let's talk about linked data a little bit, because what experience has shown is that the concept of linked data is perhaps not always that popular in the library world, and vice versa. So I think that it should be paramount to marry the worlds of IT to some extent, because linked data sort of intrudes into that world. That is part of that world. It's an IT concept, but it should be married with the world of libraries. And we, although we can never make sure that we will always be experts in every adjacent field, that is of course impossible, especially as data are growing, right? So we are talking, after all, about big data and big systems, and they are getting bigger every day. But still, I think it is paramount to have these worlds married. Now, we're talking about linked data. Many, of course, have already been working with ontologies, right? So how to teach the web semantics, that's really what the answer is, working with ontologies. But those who haven't, and again, I think this marriage between the library and the IT world is not complete. And those who haven't, what is it all about? Well, it's really about describing not just the concepts themselves, right? So different, as we had them earlier, you have educational media, you have instructional materials. Those would be different concepts, or in that case, synonyms of one concept. And they are simply connected by a line, if you will. That's what a taxonomy does. It connects these dots by lines. But an ontology goes further by describing the actual connections. So it's a bit like language. Again, coming back to that theme of language, we have a subject, we have a object, but in between there's also a predicate that exactly describes how these subjects and objects are related. And they should also be encoded in a way that machines can read, right? So is part of, for example, is such a relationship, such a predicate? Or is co-authoring a book with, or Amsterdam is a city, for example, right? That's what this is all about. And once you have a large set of these subjects, predicates, and objects, and once you really dive into the structuring of them, then they paint a picture. So a computer mouse, what is it all about? Where does it lead us to? And what new information can these interconnections then paint for us? What new picture? Now, these triple subject, object, predicate in the library world are, of course, nothing else but RDA that most of us are familiar with. So it's exactly this description of the relationship between two different points within that large grid that makes the structuring possible and good and reliable. And once we have just one such triple, it might not seem as if it were much, as if it were really leading to new information. But when we have an entire web of these predicates, and of course the subjects and objects that are connected with them, and I highlighted the predicates here in red, right? So if an edition is in a specific language, that is the predicate, being in a specific language. Who wrote that book, who worked with somebody else on writing something, then it really paints a larger picture, and it shows us gaps, and it shows us how things are interrelated. Now, another point that springs to mind when talking about these things is the visualization thereof, because what we saw on the previous slide is not always visible. That is the web in the background, but we are visual creatures. That is certainly true. That is the sense, the visual sense, that is the most prevalent in humans. So it's really no surprise that we love visualization. And MIT conducted a research some time ago and found out that 40% of the time people were actually favoring something that goes beyond just keyword search, something that even if it's just a starter, right? And then we go into text-based search and everything as we know it, starting with a visual tool helps tremendously. So what we're talking about then are the so-called knowledge graphs, or concept maps, if you will, where we are searching for something such as artificial intelligence, and then we see that the notions, the concepts that have a specific predicate, such as has kind, it's a predicate, then have then appear, and we can go through them and really see the interconnections in a very visual and graphical way. Now, what are the technologies in the background for that? And again, it's of course impossible to become an expert in any of in all of them. Rather, in any of them, yes, but in all of them, not necessarily. Especially when we are already dealing with our own world that is large enough, but then peeking sort of into an adjacent world that makes our world possible isn't always that easy. And especially when it comes to these concepts such as artificial intelligence, then machine learning, that's part of it, deep learning, that's again part of machine learning, and how exactly are they all related? And how exactly do they lead to the picture that we get when working with some big systems, such as a library system or a search index that we are using in libraries or outside libraries? How exactly did these things come about, and what exactly led to them, exactly what caused them? Now, artificial intelligence and related technologies do have their limitations. So there was this project that was around some time ago, Google's Deep Dream, and that was essentially identifying images in an automated way, right? So a bowl of spaghetti then looked to Google's Dream as if it were full of dog faces. Well, why would that be? Because it was fed with pictures of dogs. So it crawled the web, and what it found and where it was led to most of the time were apparently pictures of dogs. So are we talking about dogs here? No, we're talking about a bowl of spaghetti, and we apparently cannot always trust a machine to really recognize that as a bowl of spaghetti. So those are images, and as we saw very tangibly on the last slide, that is not always reliable. But what about language? Right. After all, most scientific data, most data in libraries are couched in language. We are talking about language, and language has many different layers. So let's give you a small example. We're talking about English, right? So how do we learn a language such as English? Well, a problem that many people encounter are the so-called big words in English. They're, by the way, not that big for French or Italian or other Romance language speakers, because they are from medieval French most of the time, or directly from Latin. So let's have an example here, right? So we have these big English words, such as suspicious, conspicuous, perspicacious, the auspices, right? Or a spectator then, spectacular, speciation, that comes from species. Now, we could go through them and learn them by heart and try to remember them. But the point is that there is a specific pattern that keeps reappearing, and that will be the Latin root, spec or speak, and there is also a specific reason why it's speak and not spec. It's specific words, and so on. You can really go into the details, and it means to watch, right, or to look at something, and that makes these words transparent. That makes us recognize patterns and understand things. But this is really just talking about the words themselves. So how about the ideas that these words convey? What about the context that these words appear in? That must be even more complicated. But since we are staying at this morphological derivational layer of a language, let's ask ourselves, would a machine really be able to recognize the pattern within this small set of words and within an entire language? Now, I think that is a question that cannot always be answered with a yes, and especially when we're talking about more complicated data, such as research data. Of course, we have to use automated means. We have to use artificial intelligence and machine learning. It's simply impossible to deal with everything manually. But the conceptual work that a librarian or a data scientist can contribute is absolutely indispensable. So it has to be a mixture of both. It has to be a mixture of machine means, but also human means and intellectual work. So there are, of course, many sources on that, many books, and also interesting videos on YouTube. Douglas Hofstadter, the one who wrote Gödel, Escher, Bach, that was quite a popular book about patents. Again, it was really about patent seeking and patent searching and patent recognition a long time ago already. He has a series of interesting videos on YouTube, and one of them is Reflections on Machine Translation and why it's sometimes misleading and why it's even more misleading when we are getting into more complicated language or perhaps into poetic language. Right, we are not always talking about poetic language when we're talking about research data, but that comes with its own complications and with its own complexities that should be taken into account. So ultimately, it's really a multiple plea at hand. I think all of us have to become a little bit more of a data scientist because these things inundate us. And be it the often very unstructured data that abound within social media, but be it also the somewhat more structured data within the library world. Of course, they are more structured, and we pride ourselves in structuring them way more than on the usual social media. But it's still the sheer amount, the sheer flood of data that really necessitates a little bit of a data scientist within each and every one of us. And on the other hand, as I already mentioned, we should be aware of the limitations of technology, right? So just a broad application of simply artificial intelligence will not lead to good results. And I think we're all familiar with machine translation, right? So Google Translate, sometimes it's good, sometimes it's really, really bad. And that's because these patterns that a human might be able to recognize more readily than a machine might not always have been taken into account. Now, since we were talking about data, a good start for those of you who might not be that familiar with the IT world, and again, I'm really pleading for that marriage of the IT world and the library world. I really recommend starting with something, again, rather trivial, but it's not really trivial because it's very, very powerful, and those would be regular expressions. So what we see on the screen is an expression that matches any email address, right? So it looks a little bit cryptic at first, but once you get into it and once you get the hang of it, it's really almost self-explanatory. But it's not just for recognizing emails, it's also for recognizing the structure of a table, the structure of an entire library, really, right? When you have these data in text format, then applying regular expressions and means that go beyond that can be very, very powerful. So how do I restructure a table? How do I understand data? How do I understand a repository, for example? How do I disambiguate author names? That is, those are all questions that regular expressions and related technologies can really help with. So in conclusion, really, I would say that structure is key, and it has always been. And as I said in the beginning, it's really a trivial observation, but then again, it always starts with the trivial things, and it might sound trivial, but it really isn't, because if we go into that, there's so much more to say about that. And when we go into the actual technologies, into actual systems and so on, there are, of course, there's a plethora of actual data and phenomena to deal with. But yes, that should be really the conclusion here. Structure is key. So feel free to reach out to me if you would like to discuss some of the things that you see on the screen right here. It's really around library technologies that I grew up with and that I love, and I plea for a marriage of IT and all things library. Thank you so much.